right, A-1 class. Today we're going to simplify radicals, and we're also going to do different operations with those radicals. All right. The first step when you're doing radicals with operations is you always simplify. It's like GCF and factoring. You always have to simplify first, okay? Key rule. So, if you look at our general rules, all right, you have this sheet. This sheet I gave you like 2 classes ago, or last class, all right? It's like the second part down. We used it for simplifying radicals as well. All right, our first rule is multiplication. When you multiply radicals, you multiply what's inside. If you look below, right here, the square root of 2 times the square root of 5, square root of 10. All right, not that bad. Okay, we basically have already done this rule, basically simplifying. Division, this is important to see. This is the same thing, okay? So if you got the square root of 4 over 9, that's the same thing as square root of 4 over square root of 9, which is 2 over 9, okay? And remember, feel free to pause this at any point. Take your time writing down these different notes, all right? You have plenty of time to do this. Press pause, whatever, okay? This next rule, square root of x squared is the exact same thing as the square root of x squared outside of it, okay? It's interchangeable. So as you can see, these are the same as well. Equal x equal 159, okay? Then our last rule we have is when we add, this is the same thing that goes with subtraction, all right? I'm going to write that down. Adding, that's terrible. Adding and subtracting have the same rules, okay? All right, multiplying and dividing don't. We're not going to do dividing yet, okay? When we add here, though, as you can see, look how the variables are the same inside of the radical. To add, they must be the same. So below that, square root of 3 and square root of 3, you can add those together, which gives you 2 plus 4, 6 square root of 3. If you had 2 square root of 3 plus 4 square root of 2, you would not be able to do that because the number inside of the radicals are different, okay? Think of that. It's the same thing as you can add 2x plus 2x, and that gives you 4x, right? But you cannot add 2x. Sorry, it's terrible writing. I don't know what it's going back to, sorry. You can't add 2x plus 2x squared. Can't add those together because different variable, different exponent. Same exact concept, okay? So, there is a sheet that I told Mrs. Locke to give you for homework. I'm going to change that to have her give it out to you right now. On the front side of that page, I want you to look at the different problems. We're going to do some of the problems on the front side of this page, all right, together so that you see that. All right, front side of the page, which is the skills practice. Operation-wise, let us start with number 12, okay? Number 12, we have 3 square root of 3 times 5 square root of 3. Okay. All right. So if we multiplied them together, this is a monomial times a monomial. I know it looks like a binomial, but it's not, because the 3 and the square root of 3 are combined by multiplication. So is the 5 and the square root of 3. So I am not foiling here. I'm doing 3 times 5, which gives me 15. Okay. And then I'm doing square root of 3 times square root of 3, which gives me square root of 9, which then gives me 15 times 3, which is 45. Okay. All right, not too bad. So 13, very similar. You've got 4 square root of 12 times 3 square root of 20. Okay. This is one of those problems that you don't have to simplify, like you don't have to do GCF and factoring first, but it really helps to go ahead and simplify. So if I simplified 4 square root of 12, I would have 4 and 3, so I can take out a 2, and that would be 2 times 4 would give me 8 square root of 3 times, well, here I could do 4 and 5, so I can take out a 2. 2 times 3 would give me 6 times square root of 5. So then that would give me 8 times 6 is 48. Square root of 3 times square root of 5 is square root of 15. Okay. All right, next, if you look at number 14, we have square root of 2 plus square root of 8 plus square root of 50. Well, at this point right here, we would not be able to add any of them together because they don't have the same number inside of the radical. Okay, they don't have the same radicand, if you remember that from our vocabulary. Can't simplify square root of 2, but I can simplify square root of 8. 4 and 2, so I can take out a 2. That leaves me with square root of 2 inside of the radical. All right. Then square root of 50. I can do 25 and 2. 25 is a perfect square, so I know I can take out a 5, and that 2's left inside the radical. And I add this square root of 2 here. So that will be 1. There's an understood 1 out here. Plus 2 plus 5 would give me 8. And square root of 2 is what's left inside of my radical. Isn't that fun? All right, if we look at 15, we've got square root of 12 minus 2 square root of 3 plus square root of 108. Ooh, that's going to be good. All right, so square root of 12, 4 and 3, can take out a 2, 3 is left inside the radical. Then I got minus 2 square root of 3, 108. I'm going to use my calculator, look at some good factors. Y equals 108 divided by x, second graph. I'm going to do 18 and 6. All right, that gives me 9 and 2. So I know I can take out a 3. That gives me 2 times 3. So I can take out that 2. So that gives me, or you can look at it like that. 3 times 2 gives me 6. And then this 3, put it triangle around it is left inside the radical. So I now have 2 square root 3 minus 2 square root 3 plus 6 square root 3. Alright, well these cancel each other out. I'm just left with 6 square root of 3. Alright. Next problem, number 16. Got 8 square root 5 minus square root of 45 minus square root of 80. Okay, can't simplify 8 square root 5. 45, I can do 9 and 5, so I can take out a 3. So I'm going to have 8 square root 5 minus 3 square root 5. Then for 80, I'm going to do 8 and 10, 4 and 2, 2 and 5, 2, 2, 2, 2, 5. So I can take out 1, 2, 2 2s. That gives me 4. Oops, there's a negative out in front there. Minus 4 square root of 5. So that gives me 8 minus 3 is 5. Minus 4 is 1. So all I'm left with is square root of 5. Alright, cool. Next, we got number 17. I got, this one looks like it's going to be kind of long. 2 square root 48 minus square root of 75 minus square root of 12. I would definitely use separate sheets of paper on these, okay? So I could do 24 and 2, that's the boring route. 12 and 2. Then I could do 4 and 3. So I know I can take out a 2, 2 2s, so 2 times 2 gives me 4. But I got to multiply that 4 by this 2 up here. It's already out there, so that gives me 8 square root of 3. 75, I can do 25 and 3. That's nice. I can take out a 5. Remember, don't forget about that negative. That's minus 5 square root of 3. Square root of 12, I got 4 and 3. Square root of 4 is 2, so I can take out a 2. Don't forget about that minus. Minus 2 square root of 3. So 8 minus 5 is 3. Minus 2 is 1, so I'm just left with square root of 3. Alright, 4 more problems left. 18. Alright, something different. I've got a binomial, 2 plus square root of 3. That plus sign makes it a binomial, times 6 minus square root of 2. That subtraction sign makes that a binomial. Binomial times a binomial, I FOIL. So I will have first 12, outer, negative 2 square root of 2, inner, plus 6 square root of 3, last, minus square root of 6. Remember, you only multiply what's inside of the radicals and what's outside of the radicals. Alright, well from there, there's nothing else that I can do, so can't combine any of them because the numbers inside of the radicals are different. So at that point, you're done. Alright. 19. I've got 1 minus square root of 5 times 1 plus square root of 5. Alright, again, binomial times a binomial. First, 1 outer square root of 5, inner minus square root of 5, last minus square root 25. So that will give me 1, and then these cancel out, minus 5, which gives me negative 4. Alright, remember, you can pause these, look back, whatever you need to do, okay? Number 20, we have another binomial. Oops. Another binomial times a binomial. Alright, first 15 outer plus 3 square root of 2 inner minus 5 square root of 7 last minus square root of 14, and then again there's nothing else you can do there, can't combine any of them. Last one we're going to do is number 21. Got square root of 2 minus square root of 6 squared. Well, remember, that's the same thing as square root of 2 minus square root of 6 times square root of 2 minus square root of 6. So we'll have first square root of 4, outer minus square root of 12, inner minus square root of 12, last minus times negative times a negative gives me positive square root of 36. Well, square root of 4 gives me 2. Square root of 12 would be 4, 3, so I can take out a 2. So it'll be minus 2 square root of 3. This would be the same, minus 2 square root of 3 plus square root of 36 is 6. So that would leave me with 8 minus 4 square root 3 as my answer. Okay. So your homework, I'm going to write it down right here, will be problems 9 through 27. Or, wait, no, sorry. 16 through 27. So the 5-6 practice sheet. You will have, sorry, looking again, 16 through 27. All right, you can look back at this video anytime you want. Thanks, bye.